they are becoming more able to put their work into words and justify their answers better through writing and through dialogue with each other and with me. And they are also able to read the examples in the book better and interpret what the texts are saying to them. So I'm finding that they're having better understanding of concepts. All right, so here's a new property for you to deal with. For every number AB where A, B equals 0, there's exactly one number, B over A, such that AB times BA equals 1. What am I proving here? Multiplicative inverse. I'm proving that that works. That's the property that proves it. And here is an example, just like what I just showed you. Okay, so that one shouldn't be hard to do, right? If I show you a problem very similar to this and I ask you to pick which property it is, make sure you go for the inverse property. And make sure you pick the inverse of multiplication and not addition, because there is no what here? Addition. There is no addition. What number when multiplied by 7/16 equals 1? Nina? 16/7. So if I have this and I multiply it, delayed reaction board today, over the reciprocal, I'm going to get 1, correct? Because I have the same two numbers on top, same two numbers on the bottom. All right, let's see who can come do number A for me. Hamp. Hamp is going to show us the multiplicative inverse or reciprocal of -7/9. He is saying -9/7. I can hear him talking it out over here. Did you agree? Thumbs up, thumbs down. Great. All right, and B is going to Callie. Callie had a little bit more work to do, didn't she? What does 2 1/12 become? She says it becomes 25/12. And now she's going to show us the multiplicative inverse, the reciprocal. She got 12/25. Thumbs up, thumbs down. I see a lot of thumbs up. Very good. Any questions about that? To divide a fraction multiplied by its multiplicative inverse. Here is my example. I have 4/9 divided by 3/5. Okay? So I'm going to take my 4/9. I'm going to change my division sign to multiplication. And then I am going to find the reciprocal of 3/5, which I know is 5/3 because reciprocal means flip it. So now I'm going to look. Do I have any shortcuts I can take? I don't see any shortcuts that I can take. I don't see any cross canceling I can do. I don't see any reducing that I can do. So I'm going to multiply straight across. 4 times 5 equals 20. And 9 times 3 equals 27. So I'm going to think to myself, do I know of a number that goes into 20 and into 27 that would help me simplify this? And I'm thinking, I know that 1 goes, but 1, I never can use 1 because I get the same answer. 2 will go into 20, but it won't go into 27 because 27 is odd. 3 will go into 27, but it won't go into 20. 4 will go into 20, but it will not go into 27. 5 will go into 20, but it won't go into 27. 6 is not going to go into either one of them. 7 is not going to go into either one of them. 8's not. 9 will go into this, but 9 will not go into that. So I know that I have simplified my answer because once I go 2 to 9 and nothing works, I really probably can stop. Well, I know that they have already worked on a jigsaw for the next section that we're going to have, and it was amazing what they were talking about. You know, what are we going to have them write? What are we going to have them read? What are we going to have them talk about as they were doing it? So they were kind of like mimicking things that I did, and through that they were learning with one another because they were planning their part of the lesson. They were going to jigsaw together, and so they were even trying to throw in some talking and writing and reading for the students, and I found that to be quite amazing. Look up here, chain note strategy. We have talked about the chain note strategy. This is where you make a comment, you correct something, or you find something that's done correctly, and you make a comment. In your groups of 3 to 4, you will each be given a different problem. I'm going to let you two work by yourself. You'll have to do back, forth, okay? You will make one comment. If you find a mistake, write down what it should be. If you see something incorrectly, tell what you found and explain how you know it's right. After 1 minute, you will pass your paper to another group member who will find something else and comment, following the directions in step 2. You will do this until every group member has commented on every problem. Does everybody understand?
When you get, like in math, when you get a problem and it goes through the steps and you try to find the mistakes. And if you find one, you say what the mistake is and then you correct it. And if you can't find anything wrong, you compliment on it and you say why you know that's right, and then you pass it to the next person to see if they found something that you missed.
So everybody get a problem. You don't have to put your name on anything. I know who your group is. Yes. The problem is already worked out. Okay, so when I say go, you're going to turn it over and you're going to look at the problem and you're going to see if the next step is correct or wrong. If it's correct, put a positive thing. If I know you do this because blah, blah, blah. If it's incorrect, you tell me what's wrong and fix it. Does everybody understand? You have 1 minute. Go. You just find one mistake. That's all one problem. That's all one problem. Yes, you write on that.
Where they messed up?
Yeah. Tell what they did wrong. And correct it. You have 10 seconds to finish your comment. 2, 1. Finish up your comment. Pass your paper to the right. Person on the end has to take it to the other end.
Okay, well, they're just going to have to...
Okay, you have 1 minute. Go.
It helped me for when I found mistakes, or when the person before me found mistakes, so that I could remember, hey, I don't need to do this on another math problem. And if they found something, or if I found something that they did right, or if somebody else found something that they did right, I can remember to do that when I do math problems.
Stop. Pass your paper to the person on the inside of the aisle, please.
They can help you, like when you get into harder things, like when I go into algebra or any other, like calculus maybe. You could remember that when you did chain notes and you get into harder problems, do it step by step and not to skip one step.
Tuesday of next week, we're going to get back in the same groups and we're going to talk about the comments that you made. Does everybody understand? We're going to look at what you found, the comments that you made, to see if you were giving good feedback or poor feedback. Now, on your desk of 4, I have given you a slip. I would like for you to answer the 3 questions. If you answer yes, then you don't do number 3 because it says if no. If you answer no, then you don't do number 2 because it says if yes. So you're going to answer 2 of the questions about the chain note strategy. I am learning that the more creative I get using the strategies and the more I use them, it is making me, it's just becoming part of my routine now. It's not something I really have to sit down and plan. When I learn a new strategy, when I implement it, I really have to plan for that. But they're just becoming natural throughout my lessons. And I don't even realize I'm doing them sometimes unless I sit down and think about, oh, I did this strategy. Oh, that was doing this. So I find myself just naturally working them in. Hope that it helped all of you think about what you have to do. Do you need one? That's okay. Think about what you have to do when you're working math problems like this. How meticulous you have to be. I felt very positively about using chain notes with my students because of some of the comments that they made on their exit tickets. Some stated that it helped them really look into the problem, and they could use that in the future to make sure that they didn't make the same kind of mistakes that were made in the problems that they were given. They also realized that one mistake can mess your whole problem up, so you've got to be careful. Make sure you include all the steps and go back and double check your work. They thought that correcting someone else's mistake was beneficial because that kept them from making the same kind of mistakes in the future. So based on the positive comments that I got from them, I thought that it went really well and that they really liked it and it benefited them. It has to be part of my instruction. It just has to be, because the students are just learning so much more with me implementing these strategies than they were before. So it's got to be life-changing for my teaching. And therefore, it's going to be life-changing for my students because they're going to be better prepared for higher level courses. And when they go to college, they're going to be able to use some of these things that I've taught them to benefit them in their classrooms, in their test taking and making notes and working things out and working with others.